Hi friends, welcome to this annual refresher program in teaching. The course is advances in agricultural engineering. So today we are going to learn the basics of soil erosion and followed by next lecture. So we are going to see how the soil erosion can be controlled using different conservation measures and structural measures. So here let's start with the basics in soil erosion. If you see this the global map, so it is clearly showing the different amounts of soil erosion across the globe. And if you see here especially India, so the soil erosion basically 5 to 20. So, in between 5 to 20 megagram per hectare per year, and then the global, if you see, about 35.9 petagram per year in 2012 was estimated, and then this is basically increased up to 2.5% from 2001. And then the cropland annual average soil erosion would be like 17 petagram per year. So, the cropland is almost contributing 50% of soil erosion globally. So, yes, in case of India, if you see, so about 16 tons per hectare annually the loss of soil is taking place. So, because of that soil loss, about 0.8 million tons of nitrogen is being lost from the fertile soil, as well as 1.8 million tons of phosphorus and 26.3 million tons of potassium is being lost from the fertile Indian soil. So, the importance of soil erosion is clearly seen in this slide. And then the next is, so the basics, if you see, the soil erosion basically it's like detachment of soil from its original position and transport to a new position. So, this is a simple definition of the soil erosion. So, broadly this been classified into geological erosion and accelerated erosion. If you see here, the geological erosion, basically this is a natural and without influence of human. So, and the loss of soil will be equal to the formation of new soil, but the thing is this will take years to form the new soil. So, it is a very slow process to form the new soils, whereas an accelerated erosion, in this case this is completely the human activity based basically. So, like you have a construction site, you have the farmlands, right. So, like roads, so all these things really we are disturbing the soil, that is really contributing or accelerating the erosion process. So, this is basically equilibrium between the soil building and the soil removal is being disturbed in this case. So, this is the soil loss and soil formation case of geological erosion which is taking place, whereas in accelerated erosion, so that's been disturbed. And then so next is so the, for example, so the basically the erosion is the two kinds of, so two basic agents. The first one is water and the other one is wind. So, here we are talking about wind erosion and water erosion, and followed by wind erosion in this lecture. So, depending on the degree of erosion, water erosion is classified as like a splash erosion, sheet erosion, rills and gullies, and stream channel erosion. So, when the rain drop falls on the soil, so when the raindrop falls on the soil, so it's basically it has a kinetic energy of 50 kmph. So, when that high speed mass is going to hit the soil particles, it's going to lose its stability with the other particles, is going to flash out. So, that's where the particles which are lose the bonding, that will be displaced from one position to another place. So, that is basically the splash erosion is going to take place. Then after that, since the continuous runoff, the particles which are flashed or detached is going to carry in a downstream, and the thin sheet of soil is being transported from its original position to the downstream. That is called sheet erosion. Whereas, if the sheet erosion continues, so what happens is further the soil dredging is going to take place because of the abrasion forces and the flow velocity. So, so the sheet is going to be concentrated flow in one place, particularly forms the rills. So, that is where the rills here, if you see the thin lines, they are going to form here, and so then all the thin lines are going to form develop further into gullies. So, the gullies are like deep and widened channels. So, then after that, so the water which is going to meet the streams and following the flow, because of the flow there will be two possibilities of causing erosion. So, that is like stream bank as well as the stream bed erosion. So, the stream channel, so will have these two possible cases of water erosion. So, then we are going to talk about individually. So, what is this splash erosion, sheet erosion, rill, and then stream bank erosions. So, in case of raindrop or splash erosion, if you see in this picture, so this is the result of direct impact of raindrop on bare soil, as I mentioned before. So, the raindrop initially will have a speed of 50 kmph, which hits the soil particles. So, the soil particle may splash to a height of 60 centimeter and then to a and then displaced to a distance of 150 centimeter laterally. So, it is basically, since these the finer particles are going to splashed out and deposited on the soil surface. So, that is going to seal the soil pores, and that definitely ultimately reduces the infiltration capacity of the soil. So, this splash erosion can be controlled with vegetative covers. Once we have vegetative cover, so that really helps in dissipating the raindrop impact and reduces the splash erosion. If you see in this picture, the first is the detachment is going to take place. The flash, once the raindrop hits the ground, the particles are going to splash out, and finally, because of the runoff, the particles will be transported down, and it will be deposited at the foot of the hill or wherever the downstream side where the velocity is reduced. That means there is no carrying capacity. So, that way so the deposition is going to take place. So, then the next is sheet erosion. If you see in this picture, the sheet erosion. So, since there are heavier particles, if you see here, there are some heavier particles are left here, that is remaining. The flow is really transported the finer particles through this, and the sheet of soil is being eroded here. So, the sheet erosion is a uniform removal of top fertile soil in thin layer from the sloping land. This is very important in case of agriculture, because the top fertile soil is very important for cultivation. So, this is the silent killer. Why it is a silent killer? Because if you cannot stop at this age or this stage, so what happens, that is going to cause the rills and further gullies. So, the severe catastrophe is going to happen. So, that is why we have to control at this stage, because it is a silent killer. If you do not stop it, and then the lot of fertile soil is being eroded. So, the crop yield reduction may be significant over the year. So, in the initial period we may not be seeing the effect of this loss of fertile soil on yield, but in the time progress, then definitely see the crop yield reduction due to the sheet erosion. So, the next is the rill erosion. Basically it's a removal of removal of soil by well demarcated channels or streamlets. If you see here, so these are kind of rills which are forming here, right. So, all rills are transporting sediments to the main, you can say, a little developed rill, and this is in future it is going to be a gully. In future it is going to be gully. So, it starts when the channels are large enough to be visible, can be easily controlled by forming operations. What happens if once the rills are formed, so that can be easily disturbed using the form operations like plowing and all, so that the rills can be leveled. So, rills can be turned into gullies if proper measures are not taken. So, this is very important. So, if you are not taking care of the rills, the definitely the advanced stage of rills is the gullies. So, gullies really carries a large amount of sediments, and so it's really deeper and wider. We are going to see how the gullies are going to form in the following lectures. See, and the next is the gully erosion. If you see the gully erosion here, it is the advanced stage of rills. So, basically if you see the initial in the previous picture, it was the small stream channel kind of things, rills. Now, it is growing bigger, like the width as well as the depth. If you see these two, so that means this is advanced stage of rills, and the water erosion at the gully head cuts the edges and caving the banks, and the retired soil is carried away from the runoff water. What happens here? So, the water which is coming from here, it's going to have a turbulence here, and then undercut the soil here, and the head advancement will be taking place. So, the dredging will be taking place from head side, right, whereas rills, see, the dredging will be taking place from this side. So, that is the difference. And then the water erosion at the gully head, basically it is going to cut, as I mentioned. So, the water which is falling here, it is going to make turbulence here and going to erode soil. Finally, this head is going to advance it further. So, results are huge quantity of soil loss is taking place at faster rate here, and it can be controlled using costly structures and practices. So, we are going to discuss those structures in the following lectures. So, next is the gully development stages. So, this is also important when you are talking about what are the stages here. So, basically the first stage is the formation stage, in which channel erosion takes place by downwards cover of the top soil. So, this is basically advancement of rills. So, if you are left with the rills, so rills are going to be developed in the into gullies. This is the first stage, this is the formation stage, and then the second stage is the development stage. So, in this case, upstream movement of the gully head and simultaneous enlargement of width and depth. So, the gully, suppose here is the gully, here is the stream channel. So, in the development stage, what happens? So, as I mentioned before, the head is going to cut further and further. So, that is what the development is taking place. At the same time, so the width as well as the depth is going to change or increased or enhanced. So, the weak parent material is rapidly removed. So, in this case what happened? So, sometimes this not only surface soil, but the subsurface soil can also be eroded in this case. So, then there is a healing stage in the sense. So, after a bigger storm or hitting in the ground, so there will be so the gully having enough width as well as the depth. Then after that what happens, the gully is no more under development stage. So, that is called the healing stage. So, vegetation begins to grow in the channel and further erosion stops. So, at this stage what happened, the vegetation in the banks as well as in the bottom is going to take place. So, that is the healing stage, and then the stabilization stage. So, in this case the gully bed and sides reach a stable slope and sufficient vegetation grows to anchor soil and trap the following form upstream. So, this is what is going to happen. Then finally, the gully is going to be stabilized with grass cover, and the new topsoil develops and vegetative cover grows. So, this is this is the last phase of gully erosion. And then the classification of gullies are basically based on the cross section. So, that is it could be a V shaped. So, when the concentrated runoff in unprotected depressions. So, if the depressions are not protected, what happens? So, it is going to form a V shaped channels. And then where only surface soil has the influence in this, whereas U shaped channels, so both surface as well as subsurface soil is being eroded here. So, that is why you get a U shaped channels like this. So, this is the V and U shaped gullies, and then the second category is based on the drainage area and gully size. So, the small gully, very small gullies which has a depth within 3 meter and width up to 18 meter. So, it is like 18 meter width and 3 meter depth. So, this is very small gullies, whereas small gullies. So, the width is same, but the depth is same, but width can go more than 18 meter. And medium gullies, so and width even width will grow as well as the depth also will grow from 3 to 9 meter. Whereas deep and narrow gullies, so the depth can be 3 to 9 meter, whereas the width can be less than 18 meter. So, the gully classification is based on the width as well as depth, like very small gullies, medium gullies, and then deep and narrow gullies. And then the last category is the stream channel erosion. So, in this case the bank erosion or the scour erosion. So, the bank erosion, basically the stream is going to dredge the sides or banks of the channel, and not only that, there is a scour erosion. So, the bed load could be eroded in this case. So, the stream channel has two possibilities. One is a stream bed as well as banks. So, stream gets widened every year, destroying the huge cultivated land as well as the roads and some kind of the towns or small villages. So, it can take whatever is coming across. So, it requires very costly and effective protection measures. So, because this is a gully, so it requires a lot of earthwork to replace and a lot of big structures to the cover with. And the this is the stream channel, of course, and the flow velocity and soil texture etc. influence the scour erosion. So, basically it depends on the flow velocity, how fast the water flow is taking place, as well as the soil texture that definitely influence the scour or this erosion. And then the next is in this case there are the two parameters are very important. One is the rainfall and as well as the runoff. So, the rainfall is very important because in order to understand the gully control measures, we should know how much rainfall intensity or the total amount of rainfall which is taking place in that particular area. So, that will lead to runoff. That will be very important in order to design the structures to control the erosion. So, So, in this case I think the last lecture I talked about some most of these rainfall measuring devices. So, the one is recording and non-recording, broadly they classified. One is Simon rain gauge and the other one is flow type or rain gauge. The Simon rain gauge gives the accumulated rainfall over a period of 24 hours or a day, whereas the flow type rain gauge gives the rainfall intensity, and because it has a graph sheet mounted on a drum. The drum is drum will be moving like a clock. So, there is a pen here attached to a float. So, when there is water which is filled with this drum or the rain gauge. So, the float is going to go upwards accordingly. The pen is going to going to write on the graph sheet based on the time. Okay. So, this is with this graph sheet, at the end of the day you come and take the graph sheet out and see the rainfall pattern here. And then the analysis of rain data is very important in order to design the water control structures, as I mentioned. So, we are going to see what is the peak flow rate which is taking place in that particular area, so that we can use that number in order to design the carrying capacity of the particular structure. So, and next is the runoff estimation methods here. So, there are many estimation methods available. So, here we are going to talk about, first is rational method. So, this is the most important method in order to determine the peak flow rate which is taking place from a particular watershed area. So, this is CIA by 360. So, where C is the runoff coefficient which can be obtained from this table. So, the runoff coefficient for in urban areas varying from 0.3 to 0.5 and forest area 0.05 to 0.2. Like agriculture, early agriculture. So, we can take this number C value from this table, and I is the rainfall intensity mm per hour for the duration of duration which is equal to the time of concentration. This is very important. It is not simple rainfall intensity. So, this is the rainfall intensity over a period for which we get the accumulated runoff for a time of concentration. So, that means the last drop of water which is taking place runoff which is taking place at the extreme end of the watershed to reach the outlet. So, this is area is the area of watershed hectares. So, we substitute all the values, you get the peak flow rate from that particular the landmass. So, then the so next is the curve number technique. This is very the very important and mostly used technique to estimate the runoff from the watershed. So, it basically calculates based on the retention capacity of the soil which is predicted by wetness status, antecedent moisture content and physical features of the watershed. So, when the soil is wet versus dry, so how in the runoff is going to take place. So, that is antecedent moisture content. So, this method assumes that initial losses are satisfied before runoff is generated. So, that is the main assumption. So, the main formula here is Q is equal to P minus 0.2 S by P plus 0.8 S. Where S is equal to 1000 divided by Cn minus 10. So, the Cn based on the land use pattern and treatment or practice adopted, hydrologic condition and soil hydrologic group, you will be getting the particular Cn number. So, once you get the Cn number, just substitute it here and you get S, that is retention capacity of the soil, and then substitute it in the previous equation here. So, knowing the rainfall depth, that is P, and you get the Q which is the direct runoff from the watershed area. So, the Cn depends on the land use pattern. So, all are here. So, like you have a pasture land, contour condition, poor, good, and then soil hydraulic group, you take anything, then substitute back, you get the runoff from this equation. So, then the next is the wind erosion. So, we finished the basics of water erosion, the next moving on to the wind erosion. So, in case of wind erosion, moves the soil from one location to another by wind power. So, basically just like water. So, the basic principle is to detach the soil particles from its original position to transport to the new position. So, that is the same thing, and it can cause significant economic and environmental damage if you are not seriously concerned, but it is mostly happen in case of desert lands and sand dunes, sandy like beaches and coastal areas, but still it is very important in case of agricultural lands, because when the soil is dry, the tremendous amount of topsoil is being eroded and transported through wind velocity. And then we are going to see how the wind erosion is taking place in different phases. So, here the wind profile clearly it is seen. First it is deflation is going to take place. So, that is the initiation of lifting. So, with that lifting there are three processes. One is called suspension. So, the particles which are finer in nature is going to be suspended in the air, and then the saltation. So, this little heavier particles are going to lift up, at the same time they are going to deposited back to the soil. So, that is the saltation, and there is a creep or surface creep. So, the heavier particles are unable to be lifted, and they are going to roll on the surface and transported to the new position. So, these three processes comprises the transport, and then finally in the one place is going to be all are going to be deposited, even the suspended particles are going to be deposited over a period of time. So, we are going to see the individual processes here in the next slides. One is the wind erosion, the initiation of the movement. So, this is important. This is the detachment of soil particles by the impact and cutting action of the wind. So, generally what happened, the wind at 15 centimeter height above the ground, if you take the wind velocity of 13 to 14.5 kilometer per hour can lift the particles of the range 0.1 to 0.015 mm or 100 to 150 microns particle size can be lifted up in the air if there is a threshold. This is the minimum velocity wind velocity required to lift these particles. If you take the wind velocity measurements at 15 centimeter above the ground surface. So, this is basically this much initial acceleration is velocity is required to lift the soil particles from the ground, and then the next process is transportation. So, transportation involves the suspension, saltation and the surface creep. So, the majority, so it contains the majority of transport, around 93% of the soil is being transported. During this process all movement takes place. It is within 1 meter height from the land surface. So, the next is we are going to see within the the transportation process. The first is the saltation. So, the saltation is the major portion, that is 50 to 75% of the soil movement is going to take place due to saltation. It is basically caused by pressure of the wind on soil particles as well as by the collision of the particles. So, not only the pressure of the wind, but also there is a collision which will bounce the particles up. So, that is what the saltation is going to take place, and then the soil particles of diameter 100 to 500 microns are mainly moved in this process. And they can cause severe damage to the soil surface and vegetation. Of course, the particles travel approximately 4 times longer in distance than the height. So, whereas in the splash erosion, so when the raindrop hits on the ground, so it like the horizontal distance, I mean vertical to horizontal distance. So that will be 3 times more than the, I mean the horizontal distance, the spread is equal to the 3 times the height of the lift. So, in case of it is a 4 times, so that is only the difference. And the second process under transportation is the suspension. So, that is basically initiated by the impact of the particles in saltation. So, so when the final particles which are taking place in this case, what happens? So, around 100 micron size are going to be lifted very easily to the suspension case, and it carries around 3 to 40% of soil waste. It lifts very high and be transported over very long distances. So, this is, if you see here, the tiny particles are going to be lifted high and then they are transported, and finally, it is deposited after a period of time. And then the third of this transportation case is the surface creep. So, basically the heavier particles like 500 micron to 2 2 mm. So, they are really transported through surface creep, and it involves basically rolling particles across. So, it is going to roll and moves I mean the downstream. It carries around 5 to 25% of total soil waste. So, it is around 25% of soil waste, and the other one is about 75%, and then and 50% of I mean the saltation is about 75%, and suspension is around 50%. So, it's all balanced almost. And then the next is, all right. So, this is the end of the lecture, and next what we are going to talk about, so how to control this soil erosion. So, thank you.